So for part two of using arrays, we're going to start with a program that will show us how do we declare an array, how do we access it, and how do we modify any values or payloads within the array, and then visualize again the memory locations in which these payloads reside and assess from what we're seeing how data is actually stored in memory. So the consecutive memory allocation will be clearly demonstrated and shown for us and how it works. So I'm going to have several programs actually to accomplish a lot of our objectives. We'll start with a simple one where we declare an array and or initialize an array. So I'll do both and we'll handle it from here. Okay, so we're starting this code from scratch. So let's go ahead and do an include statement for standard input output. And we're going to do everything in main for now. And eventually we will be in other examples using functions. And we'll be passing by reference and even returning a reference if needs be. Return 0. And let me just go ahead and do a system pause here to hold the screen for this. Let's go ahead and compile and run for this. There you go. All right, so it's just got it, nothing going on. Now let's go ahead and declare an array. All right, so how do we declare an array? What kind of data do you want to store in it? So if you wanted to store a bunch of integers, so something like this, my int array, and then you could say something like this, 5, semicolon. What you have now is an array that will store or has the capability of storing 5 integers. The advantage is they will all be stored at consecutive memory locations. All right, so what else? Well, you could do something like this, float. So it doesn't have to be an integer. My float array. You can give it 4. Okay. So it's sized up to 4 locations. Can we initialize an array as we declare it? The answer is absolutely. So you could do something like this, int my other int array. And you could do something like, now if you do this, okay, that's okay as long as you put the data that you need. Okay, so what can you store in here? Maybe 1, 2. Let's see if this will be acceptable. And let's compile it. The declare, this does not like the double slash, so we'll just put a single slash right here with an asterisk. And let's go ahead and compile here. And there you go. Okay, so this is one way to do this. So can I store other values in it? Yes, you could do an 8. You could do a -3. So I've got 4 values stored in this array right from the start. So again, compile, as you can see. No syntax error whatsoever right now. Now, can I access my other int array to see if I can see this data, 1, 2, 8, and -3? The answer is yes. You could view. So this time I'm going to put a /*, okay? View the content of my other int array. This time using an index, and then next time we're going to use a pointer. So we've got 2 ways to look at it. Okay? So I could do something like this. You could do printf, and you could say something like this, my other int array, and then you could put something maybe we could do 0 for now, just show the one that has 0, and put a percent. Now this has integers, %d. Now this is for display. The %d, however, is a placeholder. So what do we put here? My other int array 0. You are interested in that one. So let me just compile this and run it. And there you have it. So my int array 0 has 1 in it. That's the biggest I can go for this one right there. Okay, so let me duplicate this for all of them. Let me just close this one here. This is still on. There you go. I could do something else. I could do something like this. Int index equals 0. Now, what I will do is I'll put index. So I'll put a %d here for now. So we've got a couple %d, and I'll put an index here. And this one here, I'll put index. So what do you think is going to happen? So 0 will display here. 0 will display here. So I am simply doing the same thing I did before, except I have an index equal to 0. So instead of putting 0, I just want a variable in there to do the job for me. So let's compile and run here. And here you go. So now we have my other int array 0 equal 1. Okay. Now the advantage of this is I can now copy and paste and in between increment index. So what I can do now is index equal index plus 1. So this is what we call an incrementation. So if index was 0, now it's equal to 1. And then guess what we're going to do? We're going to go ahead and copy this. And notice I don't need to modify now this print statement, since the index is all you need to replace 1, right? So we now know that this is going to be 1 index, and index is 1, right? Because we've manipulated it right before the print statement. And I didn't have to write index 1 here, literally. Okay? So can I do it again where I can take this pair now, copy and paste, because it will increment to the next element. So let's go ahead and copy and paste. And let's see what happens out of this. So let's go ahead and run it, compile and run. And sure enough, we got 1, 2, 8. We still don't have -3, so we have to go one more time to access every member of the array. So now let's see how this works. Compile and run. And now we've accessed every member of my other int array using an index. Okay, good. Now, can we do the same thing using a pointer? Okay, so can we view the content of my other int array using a pointer? And the answer is yes. So first, declare a pointer. Now, what kind of data type that pointer is going to be? Well, it depends on the payload that you have inside of that array. That array happens to be holding integers. So your pointer has to be an integer type. So int asterisk, let's call it myPTR. Now, the pointer, if I put a semicolon here, that's great. You've declared the pointer. It exists in memory. It's got an allocated space for it, but it's not assigned to anything. Now, I could do something like this. My PTR equals my other int array Now you could do this, semicolon. Now you can say, wait a minute, that's not how you showed it in part 1. You did n% my other int array, 0, yes. That's one way to do it. The name of the array, in this particular case, is the actual first address of the first element. So this is one way to do it, or you could have simply done, if you wanted to, put an n%, but if you do that, make sure that you are referencing to the first element. So there are two ways to do this. You could use an address, n% my other int array, but the address of whom? The first element. Okay? The alternate, and I'm just going to write it here now, you could have done my PTR simply equal my, so I want you to experiment with that to see for yourself, int array. And it would have worked as well. So let me put a semicolon here just in case you want to reuse that code. There you have it. So now the pointer is pointing to the first element. Fantastic. So can I use that to access a data member? And yes, you can. And let's reset the index to 0 for a minute, just so I can use that for demonstration purposes. So I'm going to do index equals 0. Okay? And I'm going to use it to display. So I am going to do this part, except, so watch what I'm going to do here. Copy. Except I'm just doing it for index. Here, what I'm going to do is watch this. Star my PTR. So what is it I'm doing is I am dereferencing the pointer. And I'm just simply using the index to display 0 or 1 or whatever you want here, except the second member is going to be associated to your pointer dereferencing. Well, let's see how quickly this works. So let me put a bunch of spaces here, /n, 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 so we can differentiate between the two blocks, right? So let me compile and run here. And as you can see, it's pointing out to the first element. And this is using a pointer. Okay? So can we repeat this? And the answer is yes. But you need one extra step. You need to increment the pointer. My PTR equals my PTR plus 1. This is important if you're going to move to the next element. Okay? So that means now I'm going to copy this part here, copy, and paste it here, and see what happens, right? Remember now, not only did I increment index, so now index over here should be 1, but I've incremented the pointer. Now, that is key here. If you increment the pointer, what happens is that your pointer now is pointing to the next element. It has moved by 4 bytes automatically. That is the advantage of using a pointer. It automatically knows that it needs to move by an offset of 4 bytes to the next element because it in itself was declared as a pointer of type integer. So it knows how far it needs to move forward anytime you increment it by 1. So 1 here does not mean increment by 1 byte. It means go ahead and measure the size of this integer, right? And increment by the size of that data type. And that's really what happened here. So can we see quickly what is the result of this part of the instruction? Sure. Compile and run. And there you have it. We have 2. Now, can we go ahead and replicate this again? So notice now I'm copying these 3 here. And I'm going to paste it a couple times. Command V and Command V. Do we need more? So we need, that would be element 0, element 1, element 2, element 3. So let's see what happens. So compile and run. And there you have it. Now, we do not want to go any further. This is where it gets a little dangerous because you could easily copy and paste one more time and access memory allocation you're not supposed to be in. Let's see, for giggles, what happens if you do this. Right? So I went ahead and pushed the pointer beyond the size of the array, beyond the array allocation. Now, would my compiler catch it? The answer is no. Will this be a runtime problem? The answer is yes. So let's see what happens here. And you could see now I'm picking out garbage. Now, obviously index incremented by 1, but I'm picking out garbage in memory. At that location, this is the garbage that's in there. Now, this could lead to a lot of issues if you're mistakenly assume that is correct or a legitimate data. And then you use it in some equation or something like that. You just, destroyed your spaceship by now. Okay? So don't do that. So be careful. Always be aware of how big is your array, right? Because that's going to indicate how far into the array you're going to traverse. Obviously, there are better ways to do this than what we're doing today, and that would be loops. But I'm avoiding loops until we have a formal lecture on loops and how to do it. And then I'll come back to arrays with loops. That be it while loops, do while loops, for loops. At this stage, you want to remove these lines here because we've stepped beyond the boundary of this array. We don't want to do that. Okay, so now that we've seen how do we access and alter, I haven't shown you how to alter, how to access an array. I would like to alter an array. So we're going to do another problem. So we're going to do the same. I'm going to copy all of this. And create another program. I'm just going to go over here, paste all this here, and I'm going to go over here and call this one B. And all I need this time, I am just going to use one array that I will, this time, insert data manually myself. Okay? All right, so in this program, we're going to ask the user to enter these 5 numbers that will be stored in this array. Maybe something like this, printf. And let's go ahead and create an index. Int index equals 0, right? So we're going to use that to step through the array using an index. Okay, so here, enter an integer at my int array. We're going to call it that way. %d. Now you don't have to format it this way. I like to, show what happens to the index as we move forward. And let's do index. So what's going to happen is this is going to display my int array 0, right? And then you're going to do scanf %d. Now remember, you're entering an integer at runtime. Okay? Now, and %, remember that. You still have to put it at a location. My int array, and guess what? Index. Tell it where exactly. Well, the index is at 0. I want it to be in the first element. Perfect. What do you do after that? Now, we're going to do this, index plus plus, which is equivalent to what we've done before, index equals index plus 1. So this is a short version of writing index equal index plus 1. Okay? So we're going to do this where we're going to populate all 5 items that we need. So we're going to copy this and go to the end here. So that would be the first element, second element, right? So what happens is, well, actually from the index, so I'm just going to copy it the other way around. And let's do it. Well, I can delete the last line anyway. So first element, second element, third element. Oops. Let's do this here. Fourth element, fifth element. Sounds like a movie. I'm going to take that index plus plus. No need to increment the index. We're done there. Okay, so this is going to allow me to enter all 5 items in the array. Okay, and notice here the reason I used index, so I can generically use the same syntax throughout. So I don't have to write my int array 1, 2, 3 manually in the code. Now this is going to be very helpful when we write loops in the future. It will make it generic enough to put as one line inside of a loop. We could use now, so all of this is for data entry. This whole block of code allowed you to enter data. How about data output? And we're going to use the index again to go through this. Well, first you need to reset the index. So index equals 0. So you can go back to the first element. And now we're going to printf. So we're going to do printf. And then you could say something like this, my int array, and then index, oh, I'm sorry, %d here. Remember, it has a representative right here, placeholder, equals %d / n, give me a new line here, comma, and then put your index here, and now put your my int array index. Right? So we don't have to write 0 or 1 or 2. It will automatically do that for us as long as we increment index. Index plus plus for the next one. Well, let's see if I copy and paste this code here for all my 5 elements. So this is second, third, fourth, and fifth. And remember to remove the index plus plus. You don't need to anymore. And let's see what happens. So this will allow me to output my data out of the array out on the screen. So let's compile and run. I didn't even save this file yet. We're going to call it .c. And we're going to call this one array ex1b. This is what I want to call it. And there you go. So now it's asking me to enter an integer at my int array 0. Fine, I'll enter -9. Then it's asking me to enter an integer on my int array 1. Good, I'll enter 0. Then let's put a 33. Let's put a -6. Let's put a 11, right? So 0, 1, 2, 3, 4, we're done. That's 5 elements. And here we go. Then it will display all 5 elements. So I'm going to go back and revisit the same program, and I'm going to do pointers. So this time we've done it with index. Now I'm going to do it with a pointer. So, and let's call this one B. Okay, and let me save that. Let me just go to the other one and call it A here, which I did. Okay, excellent. All right, so I am going to copy all of this again and create another version where I am going to do the exact same work, but I am going to use a pointer, okay, to either put the data in or retrieve the data back. Now you could combine the two depending on your situation. So we're going to call this one C, okay, and I am going to keep index, except the way I'm going to reference or use my scanf. So might as well delete the whole thing here and redo it nice and clean. And we're going to do the same thing here for data output. We're going to redo it nice and clean here. Okay, so this time we're going to use a pointer. So int asterisk my PTR, and this time equal my int array. Now remember what I told you before, you could do this, which means the name of the array is the first address of the array. Or you could have said n% my int array 0, right? If you wanted to be fancy, you could have said n% index, right? So you're at 0. Fine, let's leave it there. This is one way to do it. Next, you're ready to enter the data, right? So we're going to use the pointer to associate or to the location where the data is stored or should be stored. So I need you to pay close attention because I'm going to make a slight difference in the scanf since it's already an address. It's already pointing to an address. So we're not going to need the n%. So let me be clear. We're not going to need the n% in the scanf, unlike what we did here. We had to explicitly say, hey, you know, this is an address. With pointers, you could skip that part because the pointer, the content of the pointer is an actual address. Okay, that is the key behind a pointer anyway. Well, let's go ahead and do a printf statement and ask for enter an integer at, if I could spell, integer at my int array, and we're going to put a %d here, so we'll put the index, why not, equals, and then index, right? And then here's where it's going to happen. Scanf %d. Now remember, your pointer is pointing to the first location anyway, my PTR. Now this is key here. Notice that there is no need for an %. My PTR already has the address of your array. Actually, right now it's pointing to the first element. So if you want to do anything special right now to move on to the next element, make sure you do a couple things. Index ++ and my PTR ++. You need to have these two ingredients in place to move on to the next element. Okay? And then what's going to happen is we can copy this and do this. So really what I'm setting you up here is to be able to write code for when we're ready for loops. Okay? So we're writing it generic enough where we're using the keyword index. It's not a keyword, but just a variable index. And my PTR, so we can move the pointer and the index. As you can see, the same line applies again here. So this is ripe to be inside of a loop, right? So 1, 2, 3, 4, and my fifth element. But make sure when you're done, there's no need to increment the index and or the pointer. You're done for the data entry. Now we would like to use a pointer to retrieve the data. Oh, by the way, let me save this before it's too late. So it's a .c program. And this would be array ex1 c, lowercase c. Okay. So array ex1c. Right? There you go. And as a matter of fact, I can also compile here just to make sure I didn't make any boo-boos. It looks good. All right, so now we're ready to go ahead and print, but we're going to dereference using a pointer. So printf. But remember, at this stage, when you leave off, before I do this, when you left off, you need to reset the index to 0. Remember we did that before. Your pointer, my PTR, also is pointing to the end of your list. So don't leave it there. Equals, and simply I'm just going to go ahead and do the short version, int array, which means it's going to be the first address of the array. So this is crucial here. Otherwise, you know, you're going to keep incrementing. You're going to go beyond where the array is. You need to reset it these two, the index and my pointer, back to the beginning. Okay? Back to the beginning of the array. So now, printf. We could do my int array, and then a %d here, equals, and then another %d / n, and then we're going to put index here, and then guess what? Asterisk my ptr. You need to dereference the pointer. Okay, so this is key here. Okay, well, remember index is at 0, my ptr equal the first address, so you need to move these two together, just like you did before, index ++, and then my ptr ++ need to be, these two need to be incremented. So if you repeat this 5 times, then you should be able to access all 5 members of the array. 3, 4, and 5, but remember at the end you do not need to increment the index or the pointer. You are done. Well, let's see how this behaves. So I'm going to go ahead and compile and run. Okay, so here we are. So it's asking us for the data at my int array 0. All right, let's enter a -2. Let's enter a -3. Let's enter a 0. Let's enter a 9. Let's enter a 99. Then we're done. Here they are. Okay, so this is for part 2. Part 3, we're going to go into this where, hey, are there other things we can do with arrays? Can we look at the memory locations where this data is stored? Can we pass the array or all of its content to a function?